Okay. Fine. I think I'll explain about this last example. I think. Okay. Let me check. Okay. So last, I think what we were considering is like that we have some variables, vehicle V and car C plus another was truck T, like that. Okay. Okay. I was just asking whether this one is clear. This last example. I think I'll take it again. Okay. Okay. Fine. So we are assuming here. Okay, let's assume some variables like this. Variables may be declared as vehicle V. We'll first only declare the variables. Yeah, and then we can have something like car C. We have truck T. We might have okay, let's see if we need anything else. We'll see. Okay, fine. So let's assume this, and based on this assumption, okay, somewhere you might write a code like this, right? So if V instance of, and you might say car C. Okay, if it's an instance of car C, okay, sorry, let me use without this declaration. In that case, what you might do is you can say, okay, if this is the case, right, V is an instance of car, let me declare a variable locally equal to, and I'll do casting to car for V. Okay, so that so this is like in case V is already referring to the variable called, which is of type to an object which is a car object, right? So I'll assign it to C, okay, which is of type car, so that okay, this anyway will be a redeclaration. We don't need these two. Yeah. Okay, because it's declared here. Okay, right. So that I can now use all the methods of car which can be used on C. So with C dot, fine, I will be invoking, fine, method of car, right? Not just okay, fine. After V dot, I can use any method of car and not just of vehicle alone. Okay, fine. With the variable type V, yes, I can only use methods of vehicle class. So fine, since I know it is a car, so this is the whole idea here, that you should be able to, and you can continue and use this like a car. Okay, since it's an instance of car, and then you might be writing, okay, if V instance of truck, okay, if I find there's a truck, okay, you might be doing some things which are for meant for if it was a truck, cast into a truck. Okay, V has to be cast as a truck, and then use methods of truck here. Okay, right. So if this is the way you are writing, okay, right, from Java 16 onwards, we can get rid of this declaration. It's like what we are doing is we are casting and then using it like the whatever it is an instance of. Okay, so this can, so we can rewrite this whole thing. Okay, and we can say we don't have to do this, we can just use C here, and we don't have to do this, we'll just be doing a t here, and yes, t dot, and any method of truck can be used. Okay, clear this concept? Okay, fine. Now let's just go through for these kind of hierarchy. Let's try to go through. So now the next thing what we are doing is just to confirm what kind of assignments are possible, right? Assignment and instance of. Let's check that part. Okay, so we're just checking the assignment and the instance of our knowledge on that, right? Okay, so now I'm just assuming two things, that we have vehicle V, let's say V1 and V2. The two variables V1, V2 of type vehicle. We have two variables C1 and C2 which are of type car. Okay, this is the assumption which we are making. Okay, so this is a new thing here. Okay, fine. So which of the following assignments are valid? Okay, fine. So I'll make all kinds of assignments here. So I'll say V1 equals new vehicle. So create a vehicle object and put it in V1. V2 equals new car. Okay, and that means some object of car is assigned to V2. Okay, C1 will say, okay, let's have a new vehicle here, and C2 equals new car. Okay, so which of these four are valid and which is not valid? Which assignment is okay and which is not okay? Fine. You can assign to a variable which is a same type or a super type, and we can't assign to a variable which is a subtype of what is on the right hand side. Okay, so yeah, which of these four is valid? First one, this is valid, right? What about this one? We know what is super type, what is subtype. So which is valid or not? Huh? Okay, we can assign subtype to a super type. So this is valid, right? Car is a subtype. V2 type is vehicle. Yes, you can always find. So with car, with if there is a car object, you will have methods of vehicle available on it. And so you can use it just like a vehicle only. Maybe you don't use the special things which are available for car, additional things. Okay. So this is valid. Okay. What about this? This is not valid. And this one? Okay, this is valid. Okay, now for the one which is not valid, I will comment it out. And instead, let's make an assignment like this. Fine. Null is a literal available for reference types. Fine. It can be assigned to. Fine. So here we are assigning null to a variable C1. Fine. Type is car. So we can assign null to any reference type variable. Okay. Fine. So it only means that this is not having any object, no object for C1. Okay, fine. Now with this kind of assignment, right? So now you can assume this all is execution part. Okay, this is being executed. Okay, so from that point of view, let's look at instance of now. Okay, so I'll only write some expressions involving instance of, and we have to say whether it is true or false. Instance of returns a Boolean value, true or false, right? So what about this? If I say V1 instance of vehicle, okay, we have V1 instance of car, okay. V2 instance of V2 instance of car, C1 instance of vehicle, okay, C1 instance of car, C2 instance of vehicle, C2 instance of car. Okay, so which of these are true and which are false? Yeah, this will be true or false if you assume the above assignments. Yeah. What is V1 assigned? It is assigned a new vehicle. So if I'm saying V1 instance of vehicle, it's a, and this is going to be true, right? What does V1 have? It has a vehicle. Okay, yes. What about V1 instance of car? Is it true or false? And every vehicle is not a car. And it has to be of the type. Fine, if I'm testing for car, it has to be car or a subtype of car. If I had assigned a sports car, fine, instance of car is true. But if I have assigned a vehicle, instance of car is false. Okay, fine, clear? Okay, what about this? I'm checking whether it is a vehicle. V2 instance of vehicle. What is V2 having? Which object? It is assigned a car object. So car is a vehicle. Fine. So this is true. Okay. What have we assigned? We have assigned a car. So this is true. Okay. What do you think? C1 instance of vehicle. Or you can go for this one first. Maybe. C1 instance of car. Does it have an object? No. So instance of for null will be false. Okay. So for C1, any instance of is going to return a false. Instance of anything, there's no instance. So it's not instance of any kind of thing. Okay. What about C2 instance of vehicle? We have assigned a car there. Okay. So this is true. And car is a vehicle as well as this is also going to be true. Okay. Clear on this? Instance of thing. Okay. Fine. Okay. What other operators are there? And so we have seen these operators up to instance of. Yeah. What else is there? What are the kind of operators which you might have seen in C language? Yeah. We have covered the ternary operator, conditional operator yesterday. I think we have seen that. Yeah. Okay. Now some of the things like they are termed as operator. For example, we say just the dot itself is known as a fine. This is used for so this is used for access a member. Right? So something dot and example will be okay. C1 dot invoking a method, right? So you are using a member of a so to access a member of yeah. Okay. So we are using it to access a member dot, right? We have this thing, and that's also an operator. It's a array access operator. array element, right? Okay, so it's used for accessing array elements, fine. Within this you have to specify a index position. Okay, what else is there? Any other thing? New is also many places this may be mentioned as a operator, fine. So what is this used for? You may create or you may call it as create, fine. Either you are fine, you may say allocating or creating, it's almost one and the same. Fine. Fine. Any kind of object of a class or an array. Fine. Okay, fine. So maybe there might be a few other operators, fine, but we'll see as we use them. Okay, if you have to use them, but yes, most commonly used operators, fine. We have covered them, fine. So now we can get started with statements. Okay, yeah. Okay, some common statements, right? So common use statements in Java, yes, which are those? What you find in C language? Which are the statements? Simple statements, condition statement, if. Okay, so we know if from C language, if, then this has to be a Boolean expression. Okay, then it can't be a numeric value. In C it allows a numeric value. Okay, and 0 non-zero is interpreted as 0 means false and non-zero is true in C language. In Java, no, you can't use a numeric value here. You have to have a Boolean expression. Okay, some only true and false kind of things, and non-numeric Boolean. Okay, and then you can write, you can have just single statement or a block of statement, fine. We know this, right, from C language. Okay, fine. Fine. And then it has the option of specifying a else part. Okay, again for the else, if you are having a else, fine, you'll again have single statement or a block. Okay, and that single statement or a block could again be a if. So you can have a if, and then you may have a else part, or again in the else part, the statement which you are having. Okay, this could again be a if. So if, else, if, that kind of a structuring is also there. When it's possible, right? You can do nesting. Okay, it just says statement. So that statement, the statement itself is a if statement again. Any statement is valid, right? So here also, right, in the same way here in the else part, again you might be putting a if statement, and that if may have a else part. Okay, so this is just like what you do in C language, except for the difference being that the expression is purely Boolean. Okay, fine. So we know this if else, right? Now many times that if else if structure is for what kind of thing? We have something called a switch case. Switch. Okay, how do we use the switch case? What's the syntax? Switch, and then what do we specify in the switch? Okay, now for C language, okay, I'm just giving from C language. It used to be only an integer expression. You can't have a long, you can't have any other type other than an int. Okay, of course, when I say int, char is a int only. Care, short, byte, that would be an int. So yes, switch requires an expression which is a integer expression. That is how it was. Okay. Now in Java, this is the case up to Java before Java 5. Okay, it was like this. From Java 5 onwards, okay, it could be a int expression, or fine, I'll put this kind of a thing, or it could be a enum. Okay, you can give some enum name, enum constant, not enum constant, enum type, yeah, a variable of an enum type. Okay, I'll just say it's a enum. Fine, that's from Java 5. Enums were added, so you could also specify a enum, not only long. And then from Java 7, they said, oh, we can also include string constants. So we can use strings here. The type could be a string. Okay, this is string is allowed from Java 7 onwards. So you can have switch with strings. Okay. Okay, so how do we write the switch? Yes, so we will have a switch expression followed by, so there is the body of the switch. Within the body of the switch, what do we write? We can write case, right? And we can write a case. When we say case, yes, what follows will be, right? It's a constant or a literal. It's a compile time constant. Okay, but this compile time constant of which expression? The expression has to match the switch expression. The type of the constant will be always. So if here is a int expression, then you are giving int here. Okay, if here is a enum expression, you are giving a enum constant. Or if it's a string there, yes, you will be giving a string literal, that is in double quotes. Okay, fine. So something which is compile time constant, that can be specified here, but it has to match the type. Okay, type of the expression in the switch. Okay, fine. And then each case, yeah, after case, yes, there's a character constant, a colon which was used, and we mention a colon, and then after colon you write your statements, and it can be a block of statements. Fine. You may fine, so you may just put some statements, okay, and then you can again write another case, okay, and again it would be another constant like this. Okay, so this is your constant 1, and that could be your constant number 2. Okay, and it has statements. And another additional thing I can use is default colon. Fine, you can say default colon, and then colon can be here also. Okay, and then you have the statements. Okay, and you can have more statements. Yeah, and then even after default, so it's not that, oh, they have to be sequenced like default is always at the end. You can have another case following this also. Okay, so you have a compile time constant, which is compile time constant 3, and you have statements for that also. Yeah, okay, fine. Now let us see how the execution, how the flow will be there. So if it evaluates this expression, fine, whatever is the expression of the switch, that is going to be evaluated. Next, what's the next thing? Okay, whatever is the value, it will try to match it with the cases. Okay, suppose it matched case number 2. Okay, it matched this constant number 2. Okay, the expression matched constant number 2. So if it is matching this, then it's like it would it will jump to this point. Okay, start execution of, okay, I think I'll put statements 1, statements 2, statements 3, statements 4. Okay, and let's say this is how it is. So if it is equivalent to this, what will it execute? It will execute statements 2, statements 3, statements 4. Okay, fine. This is like a go-to. We call it as a conditional go-to. Switch case is like a conditional go-to. Depending on the value, go to that particular label. Look at case as a label. Okay, from there it will start the execution and go ahead. Fine. To come out of a switch, if you want to break a switch, we have a statement called break. Okay, so if you have, fine. So normally we use a break. It's not a must. Fine. Someone wants it to be done like this. So I have arranged them in a manner. So this is an incremental execution which I want. Okay, depending on the values. So fine. So normally we have to put a break like this. Okay, we use a break statement. Now, but there is one variant of switch case which has come in, I think Java 13 or 14, somewhere around that time. Okay, the variant goes like this. When we write a switch case, okay, let me repeat this whole block again. Oh, we had to put a break statement earlier. Now it says you don't need a break if in the case you don't use a colon, but instead of colon you put this. Instead of a colon, you are putting a hyphen greater than. So there's no need of a break. It always means execute the statements for this only. Right? It's not like a go to then. It's saying, okay, this is the set of statements to be executed. Fine. Clear? So this is one variant which has come. Also, switch case is a statement, right? Can we understand difference between statement and expression? Okay. Yesterday, I think we did one operator called assignment, right? When we do an assignment, yeah, what is assignment? Is it a statement or an expression? Yeah. Is assignment a statement or is it an operator? Is it a, yeah, it's just a, is it resulting just in an expression? It is used as both the things. You may use it as a expression and you may also use it as a statement. When we use the semicolon at the end, it is a statement. Then for example, I'll tell you some common mistake which happens many times with initial developers. You might say if A equals B, where A and B are both integer types, right? So someone was intending to check for equality, but he makes this. Okay, what do you think? If A equal to B, is this valid in Java? Where A and B are integer types, let's say. In C, this would not have given an error. When in C language, if you say if A equals B, what will happen? It's used as a expression here. fine. In C, if can take a numeric expression, so it's a numeric expression. 0 or non-zero is what will decide true or false. And it's actually making an assignment here. Fine. If A and B were Boolean types, then here it is, in Java also it would be valid if it's a Boolean type, but it is resulting in an assignment happening. Whatever is B is being assigned to A. It's used as an expression. Okay, this is an expression. If A and B are integer types, this is an integer expression, and that would not be valid in the if. So that would be an error. Okay, fine. So fine. So as an expression, also as a statement, when you just use, so if someone writes A equals B, then it's an expression. It's a statement because you put a semicolon. Okay. And this is an expression. And so assignment is also an expression. You can see that. Or someone could have written like this also. If A equals B, okay, greater than 0, something like this. Okay, then it's a valid thing even in Java, where A and B are integer types. And left hand side of that relational operator is the int expression. Right hand side is the int expression, and it's making a Boolean. Okay, so this would become valid, and so based on yes the value, it would decide to execute or not execute. That's a different thing, right? So and assignment used as both the things, right? So now what why I'm talking about this is because from that switch thing, right, there is some there's a, we call it as a switch expression. So switch statement, which was only a statement earlier, is also available in the form of an expression. Okay, it's now available also in the form of a expression. I have to check Java 12 or Java 13, somewhere around that. This was introduced. Okay, switch expressions. We call them as a switch expression. So what is a switch expression? Okay. An example of that can be something like this. Switch. You have your, maybe I'm taking example of an int expression here. Okay, and within the int expression, so the cases will be integer types. Case, and what do we write in case? Maybe I'll say case 5, and here again you have both options. You can use this one, okay, and after this you may write an expression. You may write just a single statement which is saying expression. So I'm saying, okay, something like this. So what follows this thing is a expression. It's a string expression. Okay, now if this is a string expression, I might also write case 1. I'll just find, and then someone says, okay, the case is for 10, and you say default okay. So someone can write like this also. This is our switch case is this is known as a switch expression. This switch is actually an expression which is a string type. So it's possible for someone to say string word, okay, equal to this. So it's an expression and you can make an assignment. And so this results in a value, right? The code from here to here is just an expression. The type is string. Okay, I'll just change this again and let's see, just to show that yes, the variance which is there. Okay, so now someone says case 5, I don't have to write a string like this. I actually might need a whole block to do some things. Okay, but I'm still wanting to write a string expression there. So you might have some code to determine something. Okay, so multiple statements are possible in your, so for a case you are writing a block instead of a single statement. Okay, so you might have some more things here, and then how do I specify that this is the value for the expression, which has to, the result has to be a value, so and so value, right? So here is what you will say. You can't write a return. It's not a return statement. Okay, return is not valid, because what is return? Return will return the method which in which this is appearing. Okay, it will return from the method, entire method. It's just one statement, it's one switch statement, but I want to make it as an expression so that I can assign the string value. So we don't have a return. Fine, return is not valid. There is a contextual keyword called yield which has been introduced from that point onwards, and you can say yield and say yes. Okay, so some value, fine, whatever it could be. So it is possible. So we can use yield whenever we have something like a block. Okay, to say, okay, this is the value for to be considered in case if the value happens to be 5. Okay, if the value of the expression happens to be 5, then it should result in this. Okay, it's fine. Okay. Okay. So yield is another. It's a contextual keyword which has been introduced, and we have a contextual keyword for called yield. Okay, so if there is a block, yes, you can do it like this. So fine, if we are using this arrow thing, right, we don't have a break. We don't need a break statement. Okay, fine. Even with switch expression, you could have been using, but one more point here. Okay, when we use the switch expressions like this, okay, a default is mandatory, because you have listed the cases. What about the other case? I have to have a value in any case. See if it is a switch case as a statement or switch, it's a switch statement or it's a switch expression. Switch expression means your case, each case has to either yield a value, or fine, it has to yield a value, or it must have a straight away the expression itself, not multiple statements. We are just putting a straight away, oh, return this value, yield this value. So it's a, basically it's an implicit yield. Okay, so this is a, you have not explicitly got to say yield and that string. You don't have to put a yield there. Okay, fine. So it's like saying yield 1, but yield is not required to be put here. Fine. Okay. And even if you put yield, that's an error. When you just have an expression, one single statement, okay, then don't use the yield here. Okay, when it's a block, when you have multiple statements, you'll have to have a yield being mentioned. So, fine. So, since for different cases, fine, the expression may evaluate to different integer values, right? And we don't know what value it will be, right? So you will have to have some expression is always needed, because you are able to assign this to some variable. When it can be used, it's an expression. So if it's an expression, a value is a mandatory thing. It must result in some value. Okay, and therefore the default is a must. Default is a must. Clear? So in case of a switch expression, understand, switch expression means the ones which result in a value where yield is done. Fine. So those are some new features which have come at a later stage, and around 12 or 13, somewhere around that time, this switch expressions were introduced. Okay. Yeah. The next thing. So switch case. Yeah. So what are the statements we have seen? If statement, if else. Fine. We know this from C language. Then we have the switch case. In switch case, yes, it's like what was there in C. Some additional features, like in the expression, it could be a enum type or even a string type. Okay, it can be enum or it can be a string. And then we have the introduction of a where we don't have to use a break. Okay, we can use the arrow, right? Hyphen greater than, right? And then switch expression where the contextual keyword called yield is there. When I'm saying contextual keyword, because in a context this is used, it's only used inside a yield, has a meaning which is a different meaning for the language when it is used inside a case, whereas yield as such is a valid identifier outside this. Outside the switch case, if someone is saying yield, it means there is an identifier. So someone can even declare a variable by the name yield. Okay, but then within the context of a switch case, no, you don't use it that way. That identifier, it cannot be used like an identifier within the switch case, because within switch case there is a context which is created for us to use the yield with a different meaning. And so we have yield as a contextual keyword. Okay, and so it's not a pure keyword, not as a keyword anytime, and it's also usable as identifier. Okay, fine. So this is switch case. Yeah. What other statements from C language? If else, then switch. Break. We have seen break inside a, which can be used inside a switch case. Fine. Within a case, you can write a break. Yeah. What other statements are there? From C language, yes, you can speak out. Yeah. Yeah, we can have. We do have, I think, loop statements. Fine. Okay, so let's see what are the loop statements. Okay, so which are the loop statements? We have the for, okay, there's a while, and we also have a do while. Okay, this is what we have in C language. So these are similarly available in Java also. Okay, on same lines. So how was for written? We say for, and we have some initial statements, fine, to be done in the initial part of the loop, or maybe you want to start with while, maybe. Yeah. So while, yeah, what do we do? While and a Boolean expression. Okay, and you can have a single statement or it can be a block. Fine. So while for a single statement or while for a block of statements. So we understand how it is used. Fine. In C language. Fine. So it always checks the condition, executes that statement or the block of statements, okay, and tests the condition again. See, the execution will happen only when it is true. Okay, fine. So execute once, check the condition. So first time it will be checking the condition. So this is while is something which the statement may or may not even get executed even once also. Okay, 0 or n times. Okay, fine. Within this, right, it is possible to use certain statements like we can use break. Okay, break is possible. Also, we can use which other statement? What is continue statement? So just the word is just break or word is just continue. That is what we use, right? Okay. Fine. So it's a statement. The way we will use is like a semicolon, right? Break semicolon or a continue. So normally you will have within the block on some condition you might like to break, or so on some condition if you say continue, right? What would that continue mean? What is break? We understand. What will it do? Break the while, come and continue further. Come out of the while. Okay, don't even test the condition. Whereas if I say continue, what will it do? It won't proceed further in the block. Okay, continue is saying continue with the next iteration. And continue next. This one is over. The current iteration is over. You continue with the next iteration. Right? So continue is continuing with the next iteration. Okay. Yeah. Okay. So like while, we have a do while. Right? Do while. Yes. What is the difference in do while? You say do. Okay. And you will have statement or a block of statement. Okay, followed by while and the Boolean expression. Okay, and then you put the semicolon. Okay, that means that statement or the block of statements will be executed at least once. Okay, the difference between while and do while is in do while the block or that statement will be executed at least once. Okay, as compared to a while it is 0 or n times. This is 1 or n times. Okay. Condition checking is after the execution. Fine, I think. So this we know. Now coming to the for loop, yes, in C language we have a for which is written in a manner where we have to write semicolon, right? We'll say, okay, while, so sorry, it's a for, and then you might have some initial statement. This is used for initialization of some variables normally. Then you have a semicolon, okay, and then is a Boolean expression. Okay, then a semicolon, and then you have a okay I'll put it as terminal statements. Terminal doesn't mean when it is leaving, but at the end of the loop. Okay. Okay, fine. And yeah, okay. So this is what is there, and then you can have a single statement or a block of statement. And you can have a single statement or a block. Okay, fine. So this is what we know already from C language. Fine. In Java, from Java 5 onwards, okay, we have a for loop which can be seen as for. Okay, there's another, we call it as a for each loop. It's known as a for each loop. The each is not a keyword here, known as a for each loop. Okay, a for each loop is used on arrays. Okay, fine. It is used for iterating over elements of an array. Fine. Example, if I have an array, okay, let me just try with a more generic form. So if there is a type X whose array is available, so you have a variable, let me use the variable name as X array. Okay, so if it's an array of some type X, X array is an array of some type X equals, and may have been initialized maybe using the literal or maybe new and whatever, right? And it has, then maybe you have statements where you have filled up the array. Okay, fine. Later you want to iterate over all the elements of an array. You can write like this: for each, we just read it like for each X, because that's a type of elements in the array. Okay, you can have a local variable. Okay, fine, or you call it as a loop variable. So maybe let me call the variable name as X here. Okay, colon, X has not been used, X array. This is how you write. And fine, there is no index position available to you. In this, there is no index position which is available to you. Fine, and it will be so you'll just be saying, okay, so what it is doing for us is it's not giving you index. See, in case of the for loop which we write for iterating over elements of an array, fine, in the conventional for loop, not the for each loop. Okay, in the conventional for loop, you have some index position. Fine, you'll initialize. Fine. See, the equivalent thing would have been, so let's write the equivalent thing in the earlier conventional way. Int I equals 0, I less than X array dot length semicolon I plus plus, right? So this is what you normally do, right? And within this, you would be accessing, fine, you would be able to access X array of I. Okay, fine. Now, this loop which we are writing here, it's equivalent of saying that yes, X equal to X array of I. It's just nothing but it is iterating and giving us a local variable which I have created. I have called it as X. It could be any variable name you decide. It's a local variable only for the loop. So within the loop, within that for each loop, that local variable is available, and it is getting me the elements one by one from the array. Fine. Understand one thing here, you do not have the index position. Another thing, the variable which you are getting is a constant within the loop. Each iteration it will reinitialize, but you cannot modify. Right? For example, if someone says, okay, this would not be valid, right? X equal to something, okay, not valid. X is a read-only thing. X is a read-only variable. Initialization is done by it internally. When X gets initialized at the end of the loop, or rather at the beginning, each time as it begins a loop, it initializes X, and you are not allowed to change it. So you don't write any statements where assignment is done to X. That local variable cannot be assigned a new value. Clear? Yeah. Which is written? Oh. Okay. Fine, clear? Okay, I'll give some example maybe. Then you will be see where I might use. I might be writing a method, public method, which returns int. Name of the method is sum. Okay, it takes a int array as a parameter. Okay. Okay. Let's say A is the name of the array. Okay. So there is a parameter, the type is array, and I have called A. Okay. Then I can write a for loop like this. You might say, okay, I have to find some int x, or you might say sum equals 0. Okay. And have a for loop which says for each int x. Okay, I've used a variable name x. You could have used anything in A. Or maybe I'll make it slightly meaningful, different way. Values, right? This is values, and I'll just say for each value in values. And here I'll say sum plus equal to value. And this can be just saying return sum. Fine. Then no index is used. See, the only thing here, yeah, it has a restriction in the sense that you are not having access to the index position. You don't know what is the index position. Okay, so that way, yes, this is slightly has less functionality as compared to what is the conventional for loop is more flexible. Okay, this is restrictive in the sense you can't change the value in the array. It's a read-only access to the elements of the array. Okay, but this is looking simple. It's only that this is a very simple code for iterating over elements of an array. And later we'll see it's not only for arrays that it can be used for data accessing elements of a data structure. Array anyway is a data structure, but most of the data structures which are available in Java, you will be able to do a similar thing with the, so this for each is available not only for array but also for some data structures, most of the data structures I'll say. Okay, and so you will be allowed to iterate like this. Okay. Okay, so that is the new thing in Java, right? For each. Yeah. Okay. What other statements do we find in the C language? Yeah, some of the statement I just mentioned and we have used in our example here. Okay. We have statement like return. So what is return? Return is followed by optional, right? Return optionally followed by expression which matches when it has to match the return type of a method. Okay, fine. You can't return something, you can't say some expression which is not according to the return type mentioned for the method. And when you have a method, it always has a return type. Fine. It is not to be specified in case the return type is void. You just put the return, no expression. If return type is void, no expression. Right? So see, it's like anyone invoking this method will get a value because of the return statement. He is calling this method executes, and what is expected when you call this method is dependent on the return type of the method, right? So someone is expecting something to be returned from this. Okay, fine. So one thing, what happens if that method fails? Can I fail a method? See, within a method, you use a return statement to complete the method. Return will complete the method and give out a value. Okay. Same way, there is a statement which is opposite of return. Okay. We have a statement called throw. Throw, and then it's not that it's a optional part. Always when we use a throw, we have a exception object which is to be mentioned. Okay, fine. More about what this throw thing we'll look at when we come to that topic. Okay, but yes, we also have a statement called throw here. Okay, so throw is opposite of return. So uh, if you are executing a method, you will come out of a method either because of a return or because of a throw. Return means yes, the method is completed successfully and giving me back a value, or a throw means you are not getting back a value. It's a failure of this method. The method has failed. Within the method, if it executes a throw, the method has failed. An exception object is given to represent the exception condition because of which it has failed. Okay, find more about that when we come to that topic on exceptions. Okay, yeah, other statements, if you recollect, any other statements? What other statements do we have? C language, any other statements pending? Switch case, continue, break. Yeah, okay. As far as that continue and break is concerned, right? Let's look at that. So they have a variant here. Okay, before that, one more thing, right? Uh, we do not have goto. Okay, we don't have a goto statement. Okay, so there's no goto statement. Goto is there as a keyword which is not used. So you can't have an identifier called goto. That's one thing. Okay? You can't be writing a method or a variable and say I have a variable called goto. Goto is something unused. It has been knowingly kept as a keyword so that people don't get confused because someone uses goto as a variable. Okay, because it's there in C, right? It has a use in C, but not in Java. Okay, so for break and continue, we have a variant. Let's see this variant. Okay, so we call it as labeled break, and so we have a labeled break and a labeled continue. Okay, fine. So how do we use this labeled break and continue? Okay, I'll just try to give an example like this. We can write, maybe we know there is a nested loop. Yeah, fine. Fine, we can write a nested loop. So we have a for loop. So just assume it could be any for, while, or do while, any loop statement, right? So yeah, you might have written some for. Okay, that's my outer loop, loop 1, within which, though I'm using a loop statement, it could be while or do while. Fine. And some of the things would work even with switch, because break can work with a switch. So you might even internally you might have a switch statement. Okay, let me use a for statement. Okay, let me say there is some S1 is a statement here, and we have a nested loop. Okay, I'm just taking example of nested loop to understand the concept. In this nested loop, we have statement 2. Then maybe I have some if condition. So if this is the condition, I would like to say break. And you have S3 here, and maybe you have S4 here. Yeah. So now this break here, fine. Which loop will it break? Inner one or outer one? Let's say this is yeah. So this break will break which one? Inner or the outer? This will be the inner loop. But suppose I was interested in breaking the outer loop. We don't have a go-to. What is the way out? So what Java has done is, it says you can put labels for your statements. Your outer loop statement may have a label. Maybe you want to give a label. You can give any label name. Okay. Start one. Maybe someone calls it at start one. Okay, or start loop. Any kind of identifier can be used, and put a colon. So this is a label. This is the label for the outer loop, because this is immediately following this is my outer loop. You can put label here also. So you can say inner loop. Fine. So when you write a break, okay, so a break can have a label. So you can say break outer semicolon. Yeah, like this. So break can mention a label. Okay, so when we have nested like this, yes, that label could be even for a switch statement. And we know switch also has a break statement available. Fine. So if you are having a switch and then inside switch some statement is a for statement, and then if you say break, it would break the for, but I wanted to break the switch. Then give a label to the switch and give the break for the break with a label. So similar to break, labeled break, we also have a labeled continue. So continue with the next iteration of the inner loop, or is it the outer loop? Okay, so labels, right? Break and continue with labels. That is what is possible. Fine. So any questions so far? Yeah. And if you can recollect any other statements which are there in C language, statements from the language, yeah. Fine, clear with this? Yeah, any questions? No. Okay, fine. So then we proceed. Fine, let's proceed to the next topic, fine. Okay, and this is a major topic, I'll say. Fine, because now we are moving to defining a class. Right? How do we define a class? What kind of members go in a class definition? Okay, fine, we'll start with that. Or even before that, what I would like to do here is, there are a few things which we haven't set up for our batch. Okay, I would like it to be set up here. So some of the things, like, so that we can share the things. I have not yet started sharing the things here. Okay, so whatever this notes which I'm writing here, okay, the text part, fine, that we should be able to share, and I would like to share it using the Git. Okay, so it will we'll have a Git repository for this. Okay, so we have to create a Git repository. It will be done on gitlab.com. Okay, so we'll have it on gitlab.com. Okay, I think you all will be getting invites, and then you should be able to access and see these files from there, right? Okay, fine. And I think whatever changes we are making, and we'll update there. So we can start with the next topic. Okay, fine. So we're looking at defining a class. So yeah, so what is a class? And answer is class is a data type. Right? It's a data type in Java. Okay, fine. So let us create a class. Fine. Let's create our own data type. Okay. So let's create a class for representing a rectangle. Fine. Let's start with a simple class which is used for representing a rectangle. Okay. Fine. So how do we go about this? I think I'll also create a new file here. We'll have a class. This file is called. So how do we define class? Yes, we'll say class and give a class name. So we want to create a class called rectangle. Okay. So this is good enough to create a class. We know this, right? Okay. We can just say class name, and with that we should be able to define a class. Okay. Now when I do this, right, how do I use this data type? This is like defining a new data type. The name given is rectangle. What are the ways I can use this? Right? So for doing that, let's write our class with a main method. And this is class used as a data type, whereas we are writing another class to use as a application. And it's a placeholder for an application where we can write a main method. So we have another class, so we call it as class test rectangle. Okay, we want to test how the data type rectangle is being used. So we can say public static void main. And it could have been, this second class could have been written in a separate file also. Okay. And we are doing currently in the same file. Okay. And then, yeah. So, yeah, what are the ways I can, if I have a data type called rectangle, you should be able to declare variables like this. And you will be allowed to. So rectangle is a data type, and therefore I can declare variables. Okay, fine. It's a class, and therefore I should be able to create object. So it's possible to just say R1 equals new. This is how you create an object. Fine. Or someone could even set the value null to them. Fine. And then, yes, what can I do with R1? What can I do with R1? R1, R2. Yeah. Want to test the instance of those kind of things? R1 instance of rectangle? true or false, R2 instance of rectangle, true, false, that can be printed. Okay, fine. So currently what I have done is I have not put any members in my class definition. There are no members in the class definition, and this is okay. And so this has been saved as rectangle.java, and we can see that this would compile and we should be able to run. Okay, when it runs, at least some output must be given, so we may print something. So how do we want to, what do we want to print here? Okay, that may be the last statement here. Okay, and before this, maybe you want to experiment a few things. Want to print this? Okay, want to try? Fine. See, what I'm trying is we have created the object R for R1. We have kept some object of rectangle in R1. Okay, and we're saying let's convert it into a string. See, when you do a string concatenation, a conversion to string will be done. Okay, let's also do similar thing with R2. R2 is set to null, and we may do a similar thing with R2. Okay, so I think we had missed that dot, and because of that we found the problem. Okay, let me just also take care of the bin, which is directly here. This is where the things were created last time. Okay, so I've removed the bin which is in the SRC. There's a bin at the same level. Yeah. Okay, bin has rectangle class and the test rectangle. And to execute, yes, what we'll do, java minus cp dot dot backslash bin, and then we'll just specify test rectangle. Okay, fine. So creation of object is possible at this moment, and that's one thing. Just by defining a class, nothing inside it, and this is what we can do. Fine. So next, let's go and make some changes to this rectangle class and see what all can be done next. Okay. So a class can have a variable. As a member of a class, we can have declare some variable. If it's a rectangle, I might like to keep length and width in this. Okay, fine. We may keep type as int for the length and the width. So we declare variable int length, another variable called. Okay, so if I have got length and width declared like this, fine, what all can be done now? Yeah, whatever we were doing last time, oh, that's possible. But other than this, what all can then be done? We have created a new rectangle, and then here we are saying R1, right? We are printing R1, and now let's print dot Okay, so we can print the width now, length and width. Okay, fine. Because I have, see, one thing you can see here, because I have got these as members. Okay, these are actually known as instance variable. Okay, it's an instance variable. Fine. The variable which you define like this, they are known as instance variables. So a class can have instance variable. Okay, the other things, fine, we have been able to use anyway. Within a class we have already used method like main. Okay, fine. But let's see this, right, one by one. So we're going to add more members into this class definition, and we'll see their usages. So one is, yes, I can access the member, right, by I can print the member. Okay, I can like get hold of the value of the, right? I can see the value of the member, and if you want, you should be able to say r1 dot length equal to 7, r1 dot width equal to 5. Okay, fine. Let's also try, when we have these two things, let's also try those things with r2. Yeah. r2 dot length and r2 dot width. Let's try printing them. What have we done? Is there an object of in r2? We have set it to null, saying there is no object here. Okay, and then if you say, well, show me the length and show me the width of that object. Let's see what happens when we compile. Yeah, it's compiling. Fine. The type is rectangle, and therefore R2 is of type rectangle, and therefore it has a length and width. Okay, we have declared length and width, and therefore we can start using like this. Oh. And we can see what has happened. When I did find a rectangle object, we tried with R2, right? We are trying to print with R2. It says null pointer exception. Fine. There is a null from where you are trying to access the members like length and width. Okay, so accessing member there where it is null. Fine. See, compile time is not going to give an error. Okay. Fine. Okay, let's keep one more variable here. Let's have additional variable R3 also. And we can start testing, comma R3. Okay. Fine. R3 I have not initialized. This is not, this also we can make a separate object. Okay. So we have created two objects. R3 is not yet set to a value. Okay, now this is what I had done earlier. Now what I'm also trying to do is I'm trying to say R3. Oh, we have declared a variable R3, and we'll say, okay, R3 is plus R3. So what happens? What should it be? What do you expect this statement to do? This statement, r3 is n plus r3. We have used a variable r3, right? Yeah. Yeah. What is expected here? Yeah, R3 is not yet initialized. It's declared, but we have not set a value, and therefore this will not compile. You cannot use a variable, a local variable. See, what kind of variables are R1, R2, R3? They are known as local variables. They are part of a block, method block. Fine. What kind of variable is length and width? Instance variables. Okay, those are instance variables. What kind of variable is args? It's a parameter variable. Okay, we call it as a parameter variable. So we have different types of variables. We'll come across them. So one variable is a instance variable. Right? Length, width here are instance variable. Why call it as an instance variable? See, another thing I should show here is we have the class rectangle. There are these variables length and width which we have declared in the class rectangle, and someone may try to expect that, okay, let me try to use, okay, yeah, or maybe even after I have done this, maybe here someone says, oh, I want rectangle dot length. In class rectangle we have a variable called length. I want to access that like this. This is not going to compile. There is no rectangle dot length. Length is an instance variable. That means only when you have an object of a rectangle class, you will find length. Every object has its own copy of length and width. So unless you are having an object, you are not having length and width. Just by saying class name dot instance variable name is not valid. It has only to be used with a object. Okay, fine. So we have variables of type rectangle. Then on that I can use each variable may be referring to a different object. So for each object, if there is object, yes, I should be able to get the length and width as find the values for the length and width of that object. Okay, so these we call it instance variables because they have a separate copy for each instance of the class. They are related to the instance and not used otherwise. Okay, fine. So this is one. This is okay. This is an error because not initialized. Okay. And local variable has not been set a value. Okay, and then we have this I should have. So this is R1's length and width. Yes, this is what we are getting. R1 equals. So we have set a value and we might print it again. After setting the value, let's print it here. So this is like this. R1. Okay, let's do it with R2. Okay. And this can be copied and created for R2. Okay, so yeah, that rectangle dot length is a compilation error, and that we have verified.